Right, okay, so bubble sort. Right, again, I'm going to use the array notation to hold these. Right, so I'm not going to do many because it is pretty much minging. Right, so let's we'll go ascending. Right, 6 items.
So, did you share it?
Yeah, I thought I did. Oh, because it didn't post. It keeps doing that. You click the post thing and then you move away and you come back and you realise it hasn't posted.
Oh,
Is it there now?
yeah.
Yeah. It probably comes out looking quite nice on your monitors.
Not too bad.
Right, okay, so bubble sort. It doesn't know that the list is sorted. And the only way it knows that the list is sorted, there's only 2 ways it'll stop. Either it has got right down to the end and it's just looking at one number and there isn't a pair anymore. Then it'll say, right, well, stop, must be sorted. Or it did a pass and it didn't swap anything. That's when it goes, you know what? It must be sorted. So, to demonstrate this is not pleasant. We've got to show that we're looking at a pair of numbers. So, I tend to do this. Put a little marker to show which 2 that we're looking at. We're going ascending. So I look at these 2 and I say, right, are they relatively in the right order? So it's a little bit like what Quicksort does. And we say, no, they're not. So we need to swap them. Okay. So we're going to show what the original numbers were. Now, we could write it all out again, but then you end up with like a bazillion rows, and we're not doing that. No way. I'm going to try and keep to a row per pass. Right, so I'm going to do my crossing out and put a 3. I'm going to cross out and put a 4. So I'm swapping, and also to indicate to the examiner I swapped at that point, I'm going to put an S. And I can look back at that and say, did I do a swap? Did I put an S down somewhere? Right. The important thing you do now is you move to the next pair. So the next pair is here. So it's that one and that one. And even though I'm trying to keep this neat, it's going to stretch down a little bit. I'm just trying to do everything I can. Right. 4 and 12. Looking at 4 and 12, they're in the right order, so we don't have to swap anything. So we move to the next pair. Please don't take the 4 with you. We've left the 4. So the next pair is here and here. 12 and 7. So 12 and 7, they're not in the right relative order, so they need to swap. So 12 needs crossing out, and we put the 7 there. 7 needs crossing out, and we put the 12. And I'm going to indicate that I swapped. So I'm going to put an S. Just say I swapped. Move on to the next pair. So that's going to be 12 and 9. Now one thing that happens is, if you're going ascending, you're going to push the biggest value to the end. So you can see if you've gone wrong. Right, 12 and 9. They're not in the right order, so we're going to swap those over. So 12 goes, 9 goes in its place, 9 goes, 12 goes in its place. At most, just like the Quicksort, you'll have 3 numbers if you've had a double swap into that location. Okay? Hang on. I'm going to indicate that I've swapped. Yes?
Is there one use for bubble sort? If you are solely and only interested in the largest or...
No, because it's easier to... It's more complicated to write bubble sort than it is insertion sort. So why would you ever write bubble sort? Insertion sort's like 4 lines. Bubble sort's like 6 or 7 lines. It's a no-brainer. So bubble sort's going to take up more code memory. It's got more moving parts, so it's going to actually execute slower, always. There is no reason to ever do it. It's an academic exercise. There's hundreds of different sort methods, and some of them are just not very good for any production reason, but they're interesting still. They're still interesting algorithmically. Just so you can say, well, that's useless, never going to use that. Right, so we swapped these two, and we're on to the last pair, which is these two. They need to swap. They're not in ascending order. So 2 goes there, 12 goes there, and we swapped. Right, bubble sort says, right, okay, I've got this flag value. It's been set to true. We did a swap. We're going to have to do another pass. Right, what we must do is write out our list again so it's neat. Okay, otherwise you're going to make a total mess of this. So I'm just going to put my array extent markers, my square brackets, and I'm just going to write down the bits that haven't got crosses through. So I've got 3, 4, 7, 9, 2, and 12. But because the biggest item has floated to the end, don't have to look at that one again. So I shrink my space, my search space that I've got to do the comparisons on. Okay, so I am going to put a line under that just to mark it for me as that's in the right space. So I don't go too far. You could, if you wanted to, leave the 12 outside of this array, but I'm not going to do that. I'm just going to put a marker under it, and I'll just extend that line as we go along. Right, okay, so we're going to look at pairs. We want them to be in ascending order. The first pair are fine, so we're going to move on. The second pair are fine. So this is happening quite quick. We haven't had to do a swap. The third pair are fine. The final pair, because we don't want to go to the 12 because it's already in the right place, are not fine. They need to swap. So I'm going to indicate I've swapped. I'm going to update those 2 positions. And my pass is complete. But I did a swap, so I've got to do it all again. So I'm going to write out my values. So 3, 4, 7, 2, and then 9 and 12 are now sorted. Don't need to look at those. Okay. Now, this illustrates one of the things where bubble sort merges itself. We've got a number that needs to go to the front. So there's going to be endless passes here. So I'm starting with the first pair. You can write something called a bidirectional bubble sort, where once you get to the end, you go back the other way, pushing the smallest value to the front. And then so you shrink on each edge. But it's more complicated to write. And I don't actually know whether there's any performance boost. I have written it, but I've never done any metrics on it. Yeah, it's quite interesting from an algorithmic point of view to go, oh well, let's just go the other way, but move the smaller one, swap if it's smaller, bum bum bum, the right hand side, and then you're just managing where you start, where you end. So that makes it quite interesting. It is interesting. Bidirectional bubble sort. I think the last time I wrote it was in JavaScript, about 15 years ago. Right, 3 and 4. They are fine, not going to swap. 4 and 7 are fine. 7 and 2, got to swap. So 2, 7. So we did a swap, so we've got to do another pass. Bubble sort has to do another pass unless it's got down to a single item. Right, but 7, 9 and 12 are now locked into the correct positions. So we've got 3, 4 and 2. So we've only actually got two pairs to look at now. So we are getting quicker. The passes will accelerate in time. So 3 and 4, they're fine. 4 and 2, they're not fine. So we're going to swap. 2 goes there, 4 goes there. We had a swap, so we've got to do another pass. So we've got 3 and 2, but 4, 7, 9 and 12 are all locked in position, and we don't have to do anything. And this will be the final pass no matter what. So we look at this pair, they're in the wrong order, we swap them. So we put a 2 there and a 3 there. We've had to do a swap, but bubble sort's going to stop anyway because it hasn't got 2 data items. So the controlling loop that is making us run down each time is now going to end, whether we swapped or not. So our final setup is just going to be what we copy down. So 2, 3, 4, 7, 9, 12. That is bubble sort. Please don't ever, if you go into coding, write it for anything unless you're doing it as a joke. And call it quick sort or something. That'd be quite interesting. Anyone got any queries about that one? Good.